today we're going to talk about the quadrilateral family tree. But before we do that, I just want to go ahead and practice a couple of problems, as well as we have one last theorem in regards to trapezoids. So I want you all to pause this video, and I want you to try these 3 practice problems on your own. Just that way so we know where we are and what you need to review on. So go ahead and pause this video, and then when you unpause this video, all the answers will be on the board. So if you take a look, I have put all of the answers on the board for you to be able to use as a reference. The only problem that I'm going to real quickly discuss is the trapezoid. First off, you have to assume that the trapezoid is an isosceles trapezoid, otherwise you can't solve it. And the other thing I really want to stress the significance on is alternate interior angles. So if I highlight my parallel lines, I want to stress something. Notice 35 degrees and this angle up here are alternate interior angles. So if that's 35 degrees in the bottom left, then in the top right, it's also 35 degrees. But if you look at this angle here, notice that blue angle doesn't touch your parallel lines. This blue angle doesn't touch your yellow parallel lines, which shows that these alternate interior angles are in fact not congruent. They also don't even look congruent, so you know. So the one thing you need to stress the significance on is you only have alternate interior angles on a trapezoid with the angles that touch the parallel line. So this angle here and this angle here touch my parallel line, whereas this angle here and this angle here does not, which is why it is not, alternate interior angles don't work for that. So I was able to put 35 where I put 35. So then I see this triangle here. So you could have done 116 plus 35 and subtract that from 180, and y is 29. So then you know in a trapezoid base angles are congruent. So 29 plus 35 is 64, which makes z 64. And then do the same thing to find those base angles. If that's 116, this angle here is 116, but I already know this little sliver is 35. So I do 116 minus 35, and I get 81 for x. Okay, so hopefully you're okay with that, and if you have any other questions on this, make sure you come and you ask me. So let's talk about, we have one more trapezoid theorem. One more theorem about trapezoids. So this theorem tells me the mid-segment of a trapezoid is half the sum of its 2 bases. So remember, a trapezoid has 2 bases, so I would add those 2 bases up, I'd take the sum of it, and then I would take half of it to determine the length of the mid-segment. So remember, mid-segment is in the middle of your trapezoid. So my bases are your parallel sides. So this would be a base and this would be a base. I would find its sum, and then I take half of it to get the length of a mid-segment. Some people like formulas, so here would be a formula. Mid-segment equals base 1 plus base 2 divided by 2. I'm adding my bases together. I'm dividing by 2. It's going to get me the length of the mid-segment. So remember, bases, they are my parallel sides. So if we take a look at this first example, I'm going to add my 2 bases. My 2 bases are 9 and 13, and then I'm going to divide by 2. 9 plus 13 is 22. 22 divided by 2 is 11, which is the length of my mid-segment. So go ahead and pause this video and try these next 2 examples. Number 3 is working backwards, so let's see if you can figure out how to do number 3, and then unpause this video and I'll go over it. So if I take a look at number 2, I would do 5.5 plus 12.9, all divided by 2. So in my calculator, I do 5.5 plus 12.9, and then divide by 2. I get question mark equals 9.2. If I look at this next problem, my bases, I don't have both of them. So you have two different options you can do this. You can set up an equation. So you could do 4.4 plus question mark divided by 2 equals your mid-segment, which is 5.5. So then I would multiply by 2 because I'm trying to get the question mark by itself. So I'd have 4.4 plus question mark equals 11. So then I would just subtract 4.4 on both sides. So question mark equals 6.6. Or, so what some people said was I can take my mid-segment and double it and get 11, and then I could just subtract 4.4 from 11, and I still end up with 6.6. So go ahead and flip your paper. So in the beginning of the unit, I talked about how all 7 types of quadrilaterals are subsets of a quadrilateral family. So today in this box, we're going to make a quadrilateral family tree. So I'm going to highlight the border of my box, and then I have a nice story to tell. So let's keep going and hope I didn't screw this up. So, once upon a time, I had a family of quadrilaterals. Let me not write in highlighter. Quadrilaterals had 3 children. The firstborn, which was the most perfect, is a parallelogram. Parallelogram was the firstborn child, and the firstborn children are always the most perfect, which is why a parallelogram came first. And then next came the trapezoid, which is kind of perfect, but it's not completely perfect. And then its last child was a kite, and a kite was nowhere near perfect. The baby was extremely unique and had its own characteristics. So reasons why the parallelogram is the most perfect is because it has 2 parallel sides. A trapezoid is almost perfect because it has 1 parallel side. And a kite is nowhere near perfect because it's the baby and it has no parallel sides. 3 children, very perfect, very unique. However, they were all a part of the quadrilateral family. These 3 children decided to grow up, get married, and have children of their own one day. Since the parallelogram was perfect for 2 main reasons, it decided to have 2 children. It had a rectangle and it had a rhombus. A trapezoid grew up and had 1 child, an isosceles trapezoid. And a kite, the kites were the baby, and babies liked the most attention, and they did not want to share their attention with children, which is why they didn't have any children. So the parallelogram had 2 children because it has 2 parallel sides. The trapezoid has 1 child because it has 1 parallel side, and a kite had no children because it had no parallel sides. So maybe the kite was the smartest all along. So all of these children then decided to grow up, and here's where things got a little less perfect in the parallelogram family. The parallelogram side of the family, they said they were the most perfect, the best, the most amazing, until one day something sketchy happened, and a rectangle and a rhombus together combined to make a square. So, the purpose of this quadrilateral family is so that it does not, families aren't perfect, clearly, but it's also supposed to help you figure out the properties within quadrilaterals. All the properties a square has, squares have properties of a rhombus, a rectangle, a parallelogram, and a quadrilateral. A parallelogram only has properties of a parallelogram. A parallelogram cannot be classified as a trapezoid because their arrows in their family tree do not connect. A rectangle cannot be considered a rhombus because a rectangle and a rhombus don't connect. A rectangle can be considered a parallelogram and a rhombus can be considered a parallelogram. However, they can't be considered, they don't have the same properties. Okay? So the nice thing about this family tree is a lot of people write this on their notes to try to help them out as they go along. And you usually go from the bottom up to determine the properties. Properties of a parallelogram hold for a rectangle, rhombus, and square. Properties of a trapezoid hold for an isosceles trapezoid. And properties of a kite obviously only hold for a kite. So if I look at these problems down here, they're true-false questions. Sorry, my dog is growling at his toys as I'm recording this video, so I hope you get a little dose of Gus over here. But let's get rolling. Let's look at these true-false questions. Number 1, a square is a rectangle. So if I look at my family tree, is that true or false? That's true. If I look at number 2, a parallelogram is a rhombus. Can a parallelogram be considered a rhombus? That's false. You can't work backwards. Number 3, a kite is a trapezoid. That's false, because they don't share the same family lines. A rhombus is a parallelogram. That's true. A trapezoid, is a trapezoid a quadrilateral? That's also true. So pause this video, you answer the next 5 questions, and then unpause this video so you can check your answers. So all of these examples are false. So when you're good, go ahead and flip your paper. And I just went backwards here. So now I want to go ahead and verify quadrilaterals. So verifying quadrilaterals just means I'm proving that they are a type of quadrilateral. So if I look at this first question, it says, given the following coordinate points, prove what type of quadrilateral is present. What 2 formulas do you think you're going to use the most? Well, you're probably going to use the distance formula. And you're going to probably use the midpoint formula. And there's technically one more you'd use, slope. But because you have a coordinate plane, are you really going to use the slope formula? No, you're just going to apply rise over run. Alright, so I'm going to go ahead and let's plot some of these things. So negative 3, 3, that's A. 2, 4, that's B. 3, negative 1, that's C. And negative 2, that's D. So I'm not going to connect my dots. So I'm going to go over here over in this corner, and I want to brainstorm what I think this is. What does this look like to you? Well, it could be a square. It could be a rhombus. It could be a rectangle. And it can be a parallelogram. So my goal is to prove which one it actually is. So rhombus and a square are closely related, and rectangle and a parallelogram are closely related. So let's first rule out whether it's a square, rhombus, or rectangular parallelogram. What's the biggest difference between these 3, or these 4? Well, a square and a rhombus has 4 congruent sides, and a rectangle and a parallelogram have 2 congruent sides. So, or opposite congruent sides, right? So if I can prove that this side and this side are congruent, then I can rule out that it's a rectangle or a parallelogram. So I'm going to have to find the distance of AD, and I'm going to have to find the distance of DC to C. Alright, so let's do AD first. x1 minus x2 squared plus y1 minus y2 squared. So now I have negative 3 plus 2 is negative 1, squared is 1, plus 3 plus 2 is 5, 5 squared is 25. So now I have the square root of 26, and I'm just going to get that as a decimal, if my calculator will turn on. Pause, please. Let's see. All right, so square root of 26 is 5.1. So now I'm going to do DC. So the square root of x1 minus x2 squared plus y1 minus y2 squared. So 3 plus 2 is 5. 5 squared is 25. Plus negative 1 plus 2 is 1. 1 squared is 1. So now I have the square root of 26, which sure enough is going to be 5.1. So since these are congruent, I'm cheating the system here and only testing two sides. I can then probably assume those are congruent. So I know it's not a rectangle or a parallelogram. So now I got to say, okay, is it a square or a rhombus? Well, what's the big difference between being a square and being a rhombus? Well, the big difference between being a square and being a rhombus is that a square has 90-degree angles. So how do I prove that this angle right there is 90? Or their slopes have to be perpendicular. So I'd have to find the slope of AD, and then I'd have to find the slope of DC. So slope of AD. So I start on D, rise over run. 1, 2, 3, 4, 5 over 1. So that's 5. Nope, I lied. It's negative 5. And then if I do DC, rise 1, 1, 2, 3, 4, 5. DC is 1 over 5. So are my slopes perpendicular? In order for slopes to be perpendicular, they have to be opposite reciprocals, which sure enough they are. So I can conclude that this is a square. So now let's go ahead and let's look at example 2. So example 2, I'm going to plot negative 5, 0 is H. Negative 3, 2 is E, 3, 2 is A, and 5, 0 is T. So, what does this look like? This could be a trapezoid, or it could be an isosceles trapezoid. So out of those two, what's the big difference? Well, in order for the big difference would mean this and this would have to be congruent. So I'm going to have to find the distance of he, HE, and then I'm going to have to find the distance of AT, AT. So if I find the distance of he, negative 5 plus 3 squared, plus 0 minus 2 squared. So negative 5 plus 3 is negative 2. And then I have negative 2 squared. So I have 4 plus 4, which is 8. So I have the square root of 8. So the square root of 8, let's hope my calculator works again. And naturally it doesn't. What's its problem? Square root of 8, 2.8. And if I go ahead and do AT, I have 3 minus 5 squared plus 2 minus 0 squared. 3 minus 5 is negative 2. Negative 2 squared is 4. 2 plus 2 is 2 minus 0 is 2. Squared is 4. So now I have the square root of 8, which sure enough is going to be 2.8. So, isosceles trapezoid. If you need another practice problem, I recommend doing example 3 or example 4 and then bringing it to me if you have any questions. I will say the complete answer key is on Google Classroom, so you can check your answers if you want, but I'm going to go ahead and move on. I'm going to go to the bottom 2 questions. It says, determine the coordinates of the fourth point D to make a rhombus if your first 3 points are that. So A is 1, 1. B is 2, 6. C is 6, 2. So I want you to pause this video and I want you to see if you can find another coordinate for D to make a rhombus. So there's technically 3 different answers you can give me. The first thing I found is I just found the slope of A to B. So I went 1, 2, 3, 4, 5 over 1. And then I put my pencil on C and I went 1, 2, 3, 4, 5 over 1. And I plot that point right there. That would be D, which would be 7, 7. That's one point that would make a rhombus. A few other people might have found the slope from A to B. So they did up 1 over 1, 2, 3, 4, 5. And then from B, they went down 1 over 1, 2, 3, 4, 5. And they plot this point here. And notice if I plot that point there, and I connect my dots, it still makes a rhombus. Another one that they could have done is they could have found the slope from A to B. So up 1, 2, 3, 4, 5 over 1. Instead of from C going up 5 over 1, they could have gone down 5 and over 1. 1, 2, 3, 4, 5 over 1. And then this would have been another one. You only need to give me one answer. You do not need to give me 2 answers or 3 answers, but I was just showing if you got one of these answers, that does work. So go ahead and pause this video and try example 2. I will be kind and tell you that it does go off the graph, but you'll be okay. Pause it. When you finish, unpause it. The video will be on... No. Pause it, and then the answer will be on here. Sorry, I can't talk right now, clearly. So the point you should have gotten was -9, -2. How I did that was I found the slope from C to A, 1, 2, 3, 1, 2, 3, and then I just applied it. 1, 2, 3, 1, 2, 3. And yes, it goes off your graph, but that's not the end of the deal, end of the world. When this is finished and you're okay, come and see me.